Hi, my name is Kurt Johnson. Today I'm going to be talking about how to run an ionization balance from ColRadPy using adf11 file formats. So we just have a bunch of standard imports. You're going to need to specify your path to ColRadPy. This is where I have it. You then need to append the path and then finally import the ionization balance. So the first thing that the ionization balance is going to need is the location of the adf11 files. So these adf11 files were obtained from OpenADAS. This is where I have them, so they just go in as an array here. So you will need to change those to where you have them. The next thing ColRadPy needs is the ionization balance part, is a temperature grid and a density grid. So what we're going to do for this example, is we are going to plot one density and then plot the ionization balance as a function of this temperature grid here. So this is what the call to the ionization balance actually looks like. So first we're going to give it our files. We're going to give it this empty NumPy array. This does need to be there, so there's another option to run ColRadPy with adf04 files. Then this is not empty. However, when we're running with adf11 files, this needs to stay empty. You then give it the temperature grid, the density grid, and then you need to tell it that the files that it is getting are adf11 file formats. So that's going to read in those file formats, interpolate on whatever grid you want it to interpolate on, and then this next step is going to actually populate the ionization matrix. This is where it's actually going to make a array that is dimensioned number of charge states by number of charge states by temperature by density. So that will actually populate that array. The next step it's going to do is it's going to solve it, and we're going to solve it here with the time independent method. And so when it goes through and does that, you will get out a processed subdictionary, which we'll see down here. And that's where all the data is actually going to be stored from the solution. So what we're going to do is we're just going to plot it. We're going to just create a figure, and then we are going to plot all the different charge states. And you'll remember in the ion matrix itself, it is dimensioned charge state number by charge state number by temperature by density. So if we just grab the first one, that will give us the number of charge states for us to plot over. So we're going to plot here with the temperature grid versus the ionization balance. And so here's that process subdirectory with the steady state population array. And remember that this is going to be charge state by temperature by density. So we're grabbing all the temperatures and just the first density. We're going to then do some labeling on the plot, and that's pretty much it. So I will run this. So it's going to take a second to run here, just because we've chosen a fairly significant amount of temperature points. Okay, and now if I show that plot, what we have here on the x-axis is temperature. On the y-axis is fractional abundance. The x-axis is a log scale, you will notice. So what happens is this is actually the plus here, this orange charge state. The neutral doesn't exist really unless you go really low in temperature. In the next example, we'll actually see where the neutral is. But here would be the plus, the 2 plus, the 3 plus, the 4 plus, and then you would go on. And then eventually, as you go up in temperature, this would be the bare nucleus here, this pink line. So hopefully that gives you an idea on how to run ColRadPy ionization balance using adf11 file format.